All right, so once again, our objective for today is I can solve and graph quadratic equations by completing the square. And if you notice, once again, we still haven't left quadratic equations. All this chapter will be on that. We already solved them by graphing. We already solved them by factoring. Today we're going to do a new method called completing the square. Okay? That's why we didn't need the Freire model. We already know what quadratic equations are. In our steps, I gave you guys steps, 6 steps. The first one we already know automatically. We need to set the quadratic equation in standard form. Step 2, divide the entire equation by the leading coefficient. By now you should know what a leading coefficient is. Number 3, eliminate the constant. The same thing. The constant, you should know by now what the constant is. And then step 4, add b over 2 squared to each side of the equation. Factor, take the square root, write 2 equations, and solve. So all those we already know how to do. Okay? Except for today, step 4, if you notice, is the step that's being added to completing the square. Okay? So I'll give you guys some time to finish. Example 1. Copy this. It says, solve by completing the square and check your answer. Example 1, x squared minus 4x minus 6 equals 0. Example 1, solve by completing the square, check your answer, x squared minus 4x minus 6 equals 0. Copy that? Up here. So I'm going to go through all 6 steps so you guys can see. That's why I wrote them here, because it's pretty lengthy. So here we go. Step 1, set the quadratic equation in standard form. By looking at it, it's already in standard form, from highest degree to lowest degree. Step 2, divide the entire equation by the leading coefficient. Let's see, my leading coefficient on this one, it's a 1. So if I divide everything by 1, everything stays the same, doesn't it? So therefore, it's redundant. So I'm not going to actually do that step. I'm going to erase it. So I just wanted to show you what the step looks like. However, step 3, eliminate the constant. My constant here, check this out, for those of you that forgot from the homework. What is A? What is B? -4. What is C? That's why that one's C, because it's the constant. So I'm going to eliminate this constant by adding 6 to each side. Just pay attention. Don't do anything yet. Now check this out. This is called completing the square because when I do this, it's going to have a gap. Watch. I'm going to bring this down. This one eliminated, but it leaves a gap there. So this leaves a gap. To fill this gap, that's what we call completing the square. Remember when I introduced factoring and I gave you guys the shortcuts? I said, check it and see if this is a perfect square trinomial. Remember that? Square root of the first, square root of the last. Well, check this out. To find this number, we do this next step. Add b over 2 squared. So check this out. To complete the square, what is b? -4. So that means we add -4 over 2 squared. That's what we do to complete the square. And let me show you. And before I continue, but since it's an equation, whatever we do to one side, we do to the other side. So check this out. I'm going to simplify this so you guys can see what I'm talking about. This is x squared minus 4x plus, what is -4 divided by 2? -2. And what is -2 squared? +4 equals 6. And this is the same thing, right? Now check this out. This is a perfect square. That's why this move here was called completing the square. And let me prove it to you. Here it goes. I'm going to factor this because that's the next step. Open 2 parentheses. I'm going to open, in this case, I'm going to open 2 parentheses so you guys can see it. Watch. -4 goes down here. 4 goes up here. What 2 factors of 4 add or subtract to give us -4? -2 times -2. What is my first term? X and x. X minus 2. X minus 2. And what's another way of writing this? X minus 2 squared. So now, aren't these two the same? So if you were looking at a square, it has the same measurements, right? The length and the height. So now check this out. Therefore, if we already know ahead of time, if we are completing the square doing this, you don't have to do all this work. Watch. Check this out. What is the square root of the first? Square root of the last? 2. Therefore, and then we have a negative here, squared. The shortcut, right? Because we already know ahead of time that it's a perfect square trinomial. Are we there? Okay. Do you want me to leave this here to remind you how to factor this, or do I take it away so that you can do the actual the pattern? I'll leave both so you can write it and then you have that. Now check this out. Bring this down. Actually, this is 6 plus 4. 6 plus 4 is 10. Okay. Write that down, please. I'll wait for you till you're done with that. We already went through steps 1 through 5. We factored. There it is. Now I'm going to do this last process. Pay attention. First things first. Take the square root. Check this out. Square root of this, and whatever we do to one side, we do to the other side. Now, why do we do that? Let's find out. Check this out. I'm going to do a quick side step here to explain why do we do that. Okay? Watch. What is 4 squared? 16. Okay? So now check this out. And I'm not doing any magic or anything like that, so pay attention. What is square root of 16? 4. Check this out. What happened? What did it do? It eliminated the 2, right? Now let me tell you why. What is the inverse operation of a subtraction? Addition. What is the inverse operation of a multiplication? So what is the inverse of taking to the square? A square root. That's why that cancels that. Okay. Let me show you again. The inverse operation of a negative is a positive, and that's how they cancel, right? Inverse of a multiplication is division. That's how they cancel. The inverse of the exponent of 2 is a square root. That's why this was able to cancel the little 2. If you don't see it, here it goes again. What is 5 squared? So check this out. 25. What is the square root of 25? 5. Check this out. The square root eliminates that, and we're left with 5. Isn't that cool? So therefore, with that said, pay attention. Here it goes. Now that I explained that, now let me go to what we just did. It says take the square root. Whatever I do to one side, I do to the other. So the reason I do this here, because I need to get rid of this squared. So check this out. This cancels this. I'm left with x minus 2 equals plus minus square root of 10. Why do I write plus minus? Remember that was part of the quadratic formula? The quadratic equation, right? All right. Copy that, and then I'll do the next steps. So, it says here, write 2 equations and solve. But what I'm going to do, I'm just going to solve for x from right here, and then at the end I just write my 2 equations. Check this out. So, add 2, we're left with x equals 2 plus minus square root of 10. Did you ever see what I did? Yeah. So now at this point I have 2 equations. You guys see that? Yeah. X sub 1 is 2 plus square root of 10. X sub 2 is what? 2 minus square root of 10. What are these called? Roots, x-intercepts, or zeros. These are my solutions. Copy that, please. This one? It's a little 2, sub 2. This is a 1, x sub 1, x sub 2. Quick recap. Here it goes. Recap. Set a standard form. Divide the entire equation by the leading coefficient. It didn't have one, or it was 1 and stayed the same. Eliminate the constant. Yep. Add b over 2 squared to each side of the equation. That's what we call completing the square. Is that correct? That leaves us with this. That's how we factored. I showed you using Power Rangers, but I said you can also do that by doing the pattern, right? Perfect square trinomial. That's how we get this. Simplify that. And then it says take the square root to eliminate the square. And then we solve for x. So I just switched this, solve, and then I wrote my two equations. Let's do another one together. Here we go. Copy this one. Example 2. Example 2 says, same thing. You already have the instructions. I just want you to write example 2 and copy the equation t squared minus 8t minus 5 equals 0. So here we go. Step 1, is it in standard form?
Yes.
Step 2, divide the entire equation by the leading coefficient. It's 1, so it stays the same, so I'm going to leave it the same. Step 3, eliminate the constant. So that means I add 5. However, look up. When you eliminate, I want you to leave the empty space there. You bring this down, t squared minus 8t, leave the empty space that we eliminated the constant, and then at the end, 5. Why do we leave this here? Because that's when we complete the square. Are we there? So check this out. So we got this, eliminate the constant. We're on step 4. That means we need to add b over 2 squared. So look at it. Negative 8. So we're going to add negative 8 over 2 squared. Add negative 8 over 2 squared. When we do that, what? I'm sorry? No, go. Ask. Okay. So let's simplify. Here it goes. We're left with t squared minus 8t plus, let's see, negative 8 divided by 2. What is negative 4 times negative 4? 16. So this becomes 5 plus 16. So check this out. I'm not going to do the Power Rangers here because now I know that this is a perfect square trinomial. I just completed the square, right? So I'm just going to use the square root. Square root of the first, t, square root of the last, 4 with the middle sign for the middle term, negative, and I write that squared. And I bring this down but simplified. 16 plus 5, that's 21. Let's see. So we're done with factoring. What's next? Square root. Why do we need to do the square root? To get rid of the exponent of 2. Square root of this side, square root of this side. This cancels this. We're left with t minus 4 equals plus minus square root of 21. Don't forget this, guys. The plus minus after you cancel this square root here, and when you bring this down, don't forget the plus minus because this one tells us to write two solutions. Yes. So let's continue. Let's solve for t. What do? Add 4, add 4. I have t equals 4 plus minus square root of 21. So now my two solutions are t sub 1 is 4 plus square root of 21. And t sub 2 is 4 minus square root of 21. And what are these called? My roots, x-intercepts, zeros, and these are my solutions. Solutions. Yeah. No, go. You saw it? Okay. That's what I was going to say. It's just extra steps. Now, right now, if you notice, the first two I gave you did not have a leading coefficient.
So
now let's go with this one that does. Copy this one down, please. Yeah, let's do it together. Here we go. Example number 3. Example number 3. It says 3x squared minus 5x minus 2 equals 0. We're going to do this one together. Step 1. Set the quadratic equation in standard form. Is it in standard form? Yes. Step 2, divide the entire equation by the leading coefficient. What's my leading coefficient? 3. So divide everything by 3. Let's see. 3 divided by 3 leaves us with 1x squared. Negative 5 divided by 3, I'm just going to write it out. Negative 5 over 3x. Negative 2 divided by 3, that's negative 2 over 3 equals to 0. Yes?
How does the leading coefficient?
It's already in standard form. We already know that standard form. The question was, how is this the leading coefficient? This is already in standard form from highest degree to lowest degree. Remember when we did at the beginning of the year, polynomials? Standard, and then from there, the leading coefficient is the coefficient that multiplies x squared. So what number is multiplying it? 3. That's how we know that's the leading coefficient. So here we go. From there, let's see, eliminate the constant. What do? Add 2/3, add 2/3. Keep up there, everyone. Everybody's taking notes, right? This cancels, and I'm going to write x squared on the same spot, negative 5/3 x blank equals 2/3. Okay, this is where it gets interesting. Pens down, eyes up here. Here it goes. Now check this out. This says add b over 2 squared. I'm going to add. Check this out. Let me show you really quick. Remember that we cannot have fractions over fractions. Is that correct? At the beginning of the year when we got to division of real numbers, I showed you a definition as to why fractions cannot be over fractions. Therefore, but we can write them with a division sign. So check this out. For you to see, pen down please, so that you guys can see what I'm talking about. Watch. I'm going to write this. B over 2 squared. What is B here? Negative 5 over 3. So check this out. Negative 5 over 3. Doesn't this look weird? Yes, because we cannot have fractions over fractions. So instead of writing it like that, what is B? Negative 5 over 3. What does the bar stand for? Division by 2. You guys see that? Therefore, I write this right here. Negative 5 over 3 divided by 2 squared. Does everybody see it? Plus negative 5 over 3 divided by 2 squared. Okay, copy that please. And I'm going to put this over here on the side so you guys can have it as a reference. I'm going to put this right here. Did we see? Okay. I just moved it over here so that you guys can have it right there for reference. All right. So I'm going to continue. Check this out. So, what does this become? Everybody look up, please. Watch. This. Negative 5/3 divided by 2 becomes times 1/2. Yes? So therefore, this becomes plus negative 5 over 6 squared. Division, right? Okay, over 1 so far. Are you with me? Okay, negative 5 over 3. This becomes multiplication. The reciprocal is 1/2. Therefore, this is negative 5 over 6. Yes? All right. So let me go back to here. So this becomes plus negative 5 over 6 squared. Like I said, these have a lot of concepts, and you guys really need to be on your toes with these. X squared minus 5 over 3x equals to 2/3 plus that. All right? So far, so good? So now check this out. What if I did this? Pay attention, please. Pens down, eyes up here. Watch. What do we know when we have a negative inside and we're about to square it? This becomes a positive number, right? So this is going to become a positive number. Are we there so far? So if I was to to do the square of this, we already know that we're going to get a fraction, a number over another number, but it's a positive number. Now check this out. So what I'm going to do, I'm going to leave it like that. Whenever I do these that have fractions, once again, whenever we have these that have fractions, this is what I want you to do. Do not multiply this out. Leave it with a square because of this. What is the square root of the first? Square root of the last. 5 over 6, and use the sign of the middle term, squared. Does everybody see it? Now check this out. However, on this side, 2/3, we are going to square it. What is negative 5 times negative 5? What is 6 times 6? Copy that, please. Here we go. So now, before I continue, I need to add these two fractions. So everybody look up. What would be our common denominator here? 36. Right? This one's already 36. Can we make this one 36? Yes, we need to multiply times 12 times 12. This becomes 24 over 36 plus 25 over 36. So this is 49 over 36, and I bring this down. X minus 5 over 6 squared. Are we there so far? Okay, so now let's do our last steps. Step number 6. What we just did was the factoring part. You're saying, man, there was a lot of steps, Mr. Q. Yes, I've been telling you. There it goes. So, last step, take the square root. Why do we do that? To get rid of this square. So square root of this, but whatever we do to one side, we do to the other. So this becomes x minus 5 over 6. Why? Because this cancels that. Equals, plus, minus. What is square root of 49? 7. What is square root of 36? 6. And what's our last step here? Hold on. We need to solve for x, right? Add 5 sixes. Add 5 sixes to each side. We're left with x equals 5 sixes plus minus 7 sixes. And now we write our two solutions. X sub 1 is what? 5 sixes plus 7 sixes. Are we there so far? The other one is x sub 2, 5 sixes minus 7 sixes. So let's simplify. What is 5? What is 5 plus 5 plus 7 is 12 over 6, which becomes 2. This one over here is negative 2 over 6, which becomes negative 1/3. These are my roots, x-intercepts, my zeros, or my solutions. What's that? I know. Why did we what? Here? Over here? To get the common denominator. Yeah. Okay, here we go. Our homework is found on page what? 595, numbers 1 through 33 odds. I'm going to pick up homework on the way out to make sure you have your assigned progress and your homework with you. Have a good one, everyone. See you guys tomorrow. Retake today at lunch and tomorrow.